Hello, I'm Dr Sergis from the Dr Sergis Academy, and today I'd like to do another past exam question, and this particular question concerns paper 2 higher tier maths question, because the forthcoming exams now will be on paper 2 and paper 3 for the higher tier maths as well as the foundation, because the paper 1's already been done, and this particular question concerns two similar prisms. Okay, and it's quite formidable, which is why I want to go through it. Okay, so we're told that the volume of this prism and prism A are similar, and they're similar because the ratio of their corresponding dimensions are the same. So if you divide one of the corresponding lengths by the other, will be the same as one of the lengths by the other corresponding length. Okay, now as we are dealing with volumes, then we cube the corresponding dimensions as volume equals the cube of a length or dimension, because volume is a length times length times length. So we want to find the height of h. Okay, right, so let's now draw the let's sketch the actual base of volume B, and let's denote the actual height of the height of the base of volume B. Let's denote it as h subscript b, and we're given the base to be 8.1 centimeters. So hb is the height of the base of volume B, and let's denote the actual volume of prism B to be v subscript b. So v subscript b is the volume of prism B. Let's draw the actual base of prism A, and we're given the height. That's the height whose value is desired. That's the height that we need to calculate of the actual base of prism A. And we know we're given the volume of prism A. Let's denote the volume of prism A as V subscript A, and the volume of prism B as V subscript B. Okay. So if we divide the volume of prism B by the volume of prism A, then that would equal the actual ratio of their corresponding sides, but we have to cube that ratio, simply because a volume is a length times a length times a length. Now we want to find h, okay? So we need one unknown, one equation in h. So we don't know what hb is, but we're given the actual area of the base of volume B, and we know the area of the base is height times the base divided by 2. So the base times the height divided by 2 is the actual area of any triangle. Okay, so we're given the area of the base of VB to be 43.74. So the height times the base divided by 2 is 43.74. So now we can solve for the height of HB in order to write it into the equation and solve for H, the desired value, which is the height of the base of prism A. So if we solve in the normal way, HB times 8.1 times both sides by 2, and then divide by 8.1, and then we get the height of HB, and we find the height of HB to be 10.8 centimeters. So we know what the height of the base of prism B to be, 10.8. So now we can actually substitute it into the equation and find h, the desired value of the height of the base of prism A. Okay, so we know the volume of prism B to be, which is given to us, which is 1587.762. So it's 1587.762 cubic centimeters. Yeah. So we've got, that's prism. Okay, so let's write that down. So VB is 1587.762 divide by the volume of prism A, which is 58.806. Just checking everything's all right, fine. And we already calculate the height of the base of prism B to be 10.8 and divide by the desired height of the base of prism A, which we label as H. Okay. So if we rearrange the value, so first of all, don't forget, that's a cube. Okay. Now, when we divide the volume of prism B by volume of prism A, we find that it's 27. Okay, but that's equal to the cube of the ratio of their corresponding sides. Okay, so therefore, as I'll write it here, as 27 equals 10.8 over H, all cubed. Then if we cube root both sides, then we end up with just the ratio of the dimensions. So therefore, in other words, we get rid of the cube by cube rooting. So cube root of 27 and the cube root of this, we cube root the left hand side and then the right hand side, we do one side, do some of the other, we end up with 10.8 over H, and the cube root of 27 is 3. So 3 equals 10.8 over H. From which we've got one equation, one unknown in H and then so for H. So we times both sides by H, therefore 3H equals 10.8. Therefore the height, the desired height is 10.8 divided by 3. And if I just wrap up this part, so 10.8 divided by 3, and from that we get 3.6 centimeters. So therefore the desired height of the base of prism A is in fact 3.6 centimeters. I hope you enjoyed that. Thank you.